All right, so we've got this question where I've got 0.1 is at 3, -3, and 0.2 is 3, 6. So what I can do is I could go, okay, let's see, -3, 3. So let's be -1, -2, -3, and then 1, 2, 3. So right here, that's our 0.1. And then 3, 6, let's see, it's going to be 1, 2, 3. Let's see, this was 3, 3, 4, 5, and then 6. Somewhere out here, this is going to be our 0.2. We're basically trying to find the distance between these 2 points. Okay. So in trying to find the distance between those 2 points, I can create my triangle. All right. I can look at the distance between the x values, and so this is 6 here. I can look at the distance between my x values. And then I can look at the distance between my y values, which will create this triangle. Right triangle. So let's find that distance. So that distance between 0.1 on the x direction, that's 6. The distance in terms of the y direction, that's 3. And so to figure out what the total distance is, I can say that a squared plus b squared is equal to c squared. So the 2 legs are going to be 3 squared plus 6 squared is equal to c squared. That's going to give me 9 plus 36 is equal to c squared, which is going to give me 45 is equal to c squared. So I'm not done yet because I need to square root both to figure out what the answer is. So I take the square root of c squared, it's just c, and then I have the square root of 45. Now this is not fully simplified. And to fully simplify this problem, we have to look at it. We have to say, okay, if I take 45, right, I can break 45 down into 5 and 9, right? 5 times 9. And then I can break 9 down into 3 times 3. And what I often tell my students is if you have broken down your number into its prime factors, which we just did, 5 times 3 times 3, look for pairs when you're taking the square root. So basically 45 is the same thing as saying 5 times 3 times 3. So if I have the square root of 45, that really is saying the square root of 5 times 3 times 3. And what I tell my students is if you have a pair, right, imagine all the numbers inside the radical are single, okay? If they find someone exactly like them, then those 2 can become 1, they can get married and come out of the radical. Okay, so they can get married and come out of the radical. So the answer would be 3 square root 5, because 5 has to stay single inside the radical. But the key is this: when you find a pair, they become 1 when you bring them outside of the radical. So the answer is 3 root 5. Now I'm going to use the distance formula for these. So another way of saying the distance between x and y, because if I was just doing this problem, I could say, hey, what's the distance between 3 and 6? Well, it's 3. What's the distance between -3 and 3? Well, it's 6. So then I could just do 3 squared plus 6 squared is equal to our distance squared. So this is 9 plus. 3 squared plus 6 squared is equal to 30. So I got 6 squared is 36 is equal to d squared. So you got 9 plus 36, which is 45. We already talked about that in the previous video, where this is actually just 3 root 5 is equal to d. Oops. Now what we can do is if we look at the actual formula. The distance formula says, okay, what is the square root of x2 minus x1 squared plus y2 minus y1 squared? So in this case, x2, so we can say this is x2, y2, and let me change the color. Let's say this is x1, y1. So we're just plugging in, plug and check. So you plug into your formula x2 minus y2, that's going to be 3 minus negative 3 squared plus y2, which is 6, minus y1, which is 3 squared. You know, the square root, you got 3 plus 3 squared, basically, plus just 3 squared. This is going to give you 6 squared plus 3 squared, the square root is 36 plus 9, which is square root of 45. Now don't forget, we need to reduce this, so we can break down 9 into 9, or 45 into 5 and 9, which breaks down to 3 and 3. We're looking for pairs of numbers, so this is a pair. Remember, you find a pair, they become 1, and you bring it out of the radical. So you're left with 3 root 5.